to the Power Relay with Micah Clay. A series of conversations with the technicians, leaders, engineers, and innovators critical to ensuring power reliability, safety, education, and innovation. We discuss the many facets of the power industry with the unsung heroes who power the world in the 21st century. Sponsored by Southern Staffing Group, we support your power industry talent acquisition efforts. If it involves power, we have you covered. Plug in and join our host, Micah Clay, veteran, entrepreneur, and power enthusiast as we delve into the world of power.
As many of you know, we are on a mission to have 1,000 digital cups of coffee by June of 2025. While we may not reach that goal, what I found to be amazing about the journey is all of the amazing people we get to chat with. Not every person we talk with is invited to hop on the podcast, but after meeting with Madjer, I had to have him on. Joining us today is Madjer Santos, who is currently serving as the manager of T&D Engineering and Consulting for RMS Energy and is based out of Canada. Madjer is no stranger to the power industry. He started his journey as an electrical engineer in 2009 with Neoenergia and has held engineering roles with Volkswagen, Eaton, Québec, Tetra Tech, Hatch, and WSP before landing at RMS Energy. Madjer is also no one-trick pony. While he is very adept in the T&D world, Madjer is also a rock star on the PNC side as well and knows his way around a high-voltage substation. Madjer, many thanks for taking the time out of your busy schedule to join us. Can you tell our audience a little bit more about yourself?
Hey, thank you. Thanks for having me, Micah. It's a big pleasure to be here and to be part of your podcast, which I admire a lot.
Thanks.
So yeah, a little bit of my background. I was born in Brazil. I went to Electrical Engineering University there. I finished my studies in 2009 and started my career in the same year. First, I worked there a couple of years in a distribution utility, as you mentioned. Today it's called Neoenergia, but back then it was Electro, before it was acquired by Iberdrola. And it was my first opportunity, my first work there in Brazil. And I started working with substation maintenance, substation design, field testing and commissioning, support to real-time operations. I spent, I believe, 4 years there. It was a pretty good another school, I would say, another a university, because for the first time I was having the opportunity to see things and to work in real projects. It's very different from university. So it was the best first job that I could have ever had.
Absolutely.
And then I moved to project management. I was very interested in project management at that time. I did an MBA in finance and also in business administration. And I was planning to go to this area, so I picked a job at Volkswagen, working as a PM in a big factory expansion project, actually. And I was the PM for all the electrical sub projects, including 2 medium voltage substations. But then the plans changed a little bit. We decided to move to Canada, and I've been living here in the beautiful and cold province of Quebec since then.
Definitely a little cold up there. I've spent a little bit of time up there myself,
pretty
and the winters are
pretty cold, yeah, and snowy. We're actually having a snowstorm here. I don't know, 1 feet of snow today.
Definitely.
But we like it. It's been we're going to complete 10 years now in September.
Very cool.
So,
that is awesome.
so that's it. I was planning to go to management when I was in Brazil, but when I moved to Canada, I actually started interviewing for project management roles, but my first job offer was from Eaton to work with SIME software. And it's a software that is largely used by distribution utilities in North America. And then I said, okay, let's work with technical again a little bit, and then we get to the management side of things later. And I just love that, and I'm doing that until today, basically. So I worked 2 years there. Then I moved to Hydro-Québec for a couple of years, and here I really started to specialize in PNC and substation design. So it was in Hydro-Québec that I programmed my first relay, for example, and I did my first protection coordination study. So it was another big opportunity to learn, and I started to fall in love with PNC actually.
I love that.
And then yeah, it's crazy. It's crazy. I just love relays. I think I think that, for example, not much of engineers I know love to open a relay manual
Right.
with 1,600 pages and just, okay, let me let me find what I'm looking for, the information, and I enjoy it a lot. I really love to open a relay manual and read it and find information I need. So it was kind of a love at first sight, I'd say.
Well, and that's one of those
So
things, man. And I hate to interrupt the bio section, but I just
no,
find
no,
it
no.
truly. You don't often run across an engineer that's willing to get out there and do the relay protective schemes and do
Mhm,
all the stuff, and it makes you such a much better engineer, in my humble opinion, from the outside
mhm,
looking in, and to be able to do all the things and understand the pain points for the field service bubbas that are out doing the work day in and day out, and you have the
mhm.
ability to kind of bring those pieces together. So I think it's awesome, and kudos to you.
That's it. That's it. And then after Hydro-Québec, I moved to consulting. I worked for companies like Tetra Tech, Hatch, WSP, and now since 2024, I'm a manager, T&D Engineering and Consulting at RMS Energy. So I'm kind of bringing back that management love as well. But I don't plan to keep the technical side of my work aside. I want to keep doing technical stuff because that's what I love most.
That's awesome just
Um,
to have that
so
passion.
that's it. So in the last 5 years, I focused on PNC and substation design for T&D and renewables, but also did some studies and design work for data centers and industrial customers as well. So I think that's it about me in a nutshell. In my spare time, I like to read, play the guitar,
Beautiful.
exercise, spend time with my family, and play a lot with my 4 years old son.
You got to love that, man. And there's nothing wrong with that. I'm of the same mind. I just enjoy being the father side of it more than anything. And that is such a fantastic
That's it.
backstory. And I always like to ask the question. So we understand you have a passion for this stuff, but what initially kicked that off? What inspired you to become an electrical engineer?
Oh, that's interesting because I really had no role models at all. My dad served as a policeman, and my mom was a teacher in primary school. They are both retired now. I was actually the first person of my family to go to university and get a degree. So I think it was all by instinct. I followed my nature. And so why electrical engineering? I had never met an electrical engineer in my life when I decided to become one. So there was this large hydroelectric plant near my city, and we passed in front of it when we traveled to the biggest city that we went there to buy stuff or to go to a doctor because the city I lived in was a very small 8,000 people, and 8,000 people in Brazil, it has nothing, basically just people in basic services. So we traveled a lot, and every time I passed in front of this large hydroelectric plant, and sometimes the spillway gates were open, and all that water, going through, and I just looked into that, and I thought with myself, I just wanted to know what is going inside.
That makes sense.
I
Yeah.
need to know. I need to know what is going inside because it's beautiful, it's big, it's enormous, and it's so powerful. And I just it got my interest. And that inspiration, let's say, combined with the fact that I was good with physics and math at
I was
school.
about to say, usually there's a curiosity surrounding the physics and math elements
That's
of
it.
it, you know.
That's it.
So
I was good at physics and I enjoyed a lot maths. And I was one of those kids also that disassembled all his toys to see what was inside. So I just said that to my mom. Oh, why not engineering? And they said, and she said, yeah, that the engineering's a good one. Okay, it's a good one. So let's go for that. So that's the beginning of the story.
that is awesome. That is very, very cool. And there's usually like some pivotal moment, you know, like there's that curiosity that we all kind of share. And even though I know I'm practicing, that's what my formal education was in electrical engineering as well. And it's
Hmm.
just, I've always had that curiosity as well. And my dad used to get so mad. We'd be taking apart like lawnmowers and putting the engines on go-karts and all sorts of just random things that kids shouldn't do. It's very Little Rascals-ish from back in the day. So I totally get it. And to that point, love of the physics, love of the math, and that seems to be a reoccurring theme every time we have these conversations. And
Yeah.
so that kind of talks to the electrical engineering. Was there a pivotal moment that kind of said that you said, Madjer, I'm ready to go into the T&D world or anything like that? What drove your emphasis post engineering? So because we all know there's 20 different career paths and
Yeah.
tracks. You can go distribution, you can go generation, whatever it may be. What drove you towards T&D?
Yeah, actually, when I was going to university, I had two choices: electronics or power systems. And I think I chose power systems because of I knew that power systems was big stuff, and electronics were small stuff.
Awesome.
So that's all the information I had at the time, and I wanted to work with hydro dams and substations and
All the
big stuff.
big
So
stuff.
I said, let's pick power. Yeah. So I went to university and I did the concentration of my electrical engineering degree in power systems. And then I was lucky enough to start my career in T&D. My first project in Neoenergia, as we talked, was to structure a training for a substation maintenance program. So I was in the field for a couple of months with the field technicians, and I was going with them do the maintenance practice of all substations equipment, transformers, circuit breakers, everything, PT, CTs, relays, control houses, emergency generators, everything. So my job, my first assignment, and it was actually my internship project, was to create the material and structure the training, because everything was done, it was passed through experience. The
Hmm.
newer technicians learned from the older ones,
Yep.
and they kept doing the same practices, but and nothing was documented. So I went to the field and I accompanied all this practice, all this maintenance practices, and I took photos and I wrote all the training material for that. I believe it was 800 pages, something like
Oh,
that.
wow.
At the times, I think it was 10 or 11 different equipment, pieces of equipment. So I learned a lot.
I bet you
And
did.
so I started to say, okay, I never leave T&D. So that's I just started with T&D. And a fun fact about that is that when I was in my first week in my first job, there was a big blackout in Brazil. I
Oh,
believe
wow.
80% or 90% of the country was out for
Wow.
10 or 12 hours. It was one of the biggest blackouts in all history. I think they lost the transmission, the HVDC link between Itaipu, which is
That's
the
like the
third
utility,
biggest.
basically, right? Yeah.
Yeah, and we lost the HVDC link between Itaipu and and São Paulo, the biggest load center. So it was a mess, and I remember I worked too late to help the people to get data and to understand, and it was crazy, man. Everybody was crazy
I'll bet
on
it
the control
was.
room.
And
So this was my first week, you know. So how not get
Nothing like getting
passionate
thrown
about
into
it?
the deep end really, really fast, you know? Wow.
That's it. So that's what how I landed in T&D. Worked in industrial projects a little bit, but then since I restarted my career in Canada as soon as I jumped into T&D, and I said, okay, that's my work. That's my word, and I love it.
That is awesome, and obviously, like that has a big tie into the distribution side of it, transmission distribution.
Hmm.
There's a substantial amount of P&C work that's involved in that as well
Hmm.
from control. That's another kind of subset of something, and we touched on this earlier, like the value add of having both the engineering background to be able to do the design elements, but also to have the practical knowledge to go out to a control house and see and
Hmm.
install the relays and go through the settings and know what's important is through fault monitoring, set and all the other little things that are nuances that typically, unless you're out doing the work, you may not necessarily understand it. And that's been my take on it from various conversations. What's your take? Do you see there's benefits added to being the engineer that goes out and does the work, or what are some of the pros and cons? Would you have changed anything on that journey, and kind of, or do you wish you would have spent more time in the field, or what's your take on that?
Hmm. I wish I would like to had spent more time in the field. I spent some time in the field early in my career, but after we start to build a family, it's a little bit more difficult to travel a lot, and our working is spread around all the places and substations and facilities. So I was looking up to have this opportunity at the beginning, and I think it's very important, and it's key, especially for young engineers. I think they should spend some time in the field, as I did myself, and there's a lot of benefits. I think actually see the equipment that you learn about in the university, let's say, how things are connected, troubleshooting, and a downside maybe is, okay, I'm going to a substation and I don't know what's going on. I remember first time I was in a substation, I thought everything was the same thing because of the isolators, and said, oh, why this is a CT and this is a surge arrestor. For
Right.
me, it's the same thing, isolators, and when you're starting and you jump right away into technical into field work, sometimes it can be daunting. But I think it's really quickly you start to figuring out how things are connected, and how things work, and how the people that work on the field, their knowledge is also amazing, and
Mm-hmm.
there's a big amount of knowledge there, and you start to talk to these people, and they talk about events that occurred in the past, and how things went wrong and how they fixed things, and there's so much knowledge and so much inspiration in the field work. And even if they for example, thinking about a young engineer going to the field, even if they don't understand everything yet, they will connect the dots later. that's uh,
Absolutely.
that's the big takeaway. So yeah, I'd like to do more field work today, but I'm pretty comfortable with the design work as well. So I think, let's put that way. If you if you if you just see DC schematic for the first time and you try to understand what is going on without actually, had the opportunity to see that in the field, it would take more time for you to understand what is going
I
on.
agree.
So I think this field experience speed up the learning after when you go to design work, for example.
It just, like you said, it just seems like now you actually get to visually, like you're engaging all the various learning
Yeah,
modalities that we have, right? Your visual, your audio, and then repetitions, and now taking the ethereal and now tying it to what's happening in the real world application, basically.
exactly.
I think it's amazing. So good
That's it.
stuff. And so we'll kind of go to more of a macro trendish level here. And this is one of those things. I did a deep dive into power before we planted our flag for Southern Staffing and saying, hey, this is our industry. And I know you and I talked about this at pretty good length when we had our digital coffee, but macro trends in the industry. What are you seeing for power industry as a whole? We slowing down, we speeding up. What's your take on what's going down in the power industry writ large?
Yeah, I see a very big boom in our industry right now. I think it's we cannot deny that. And I think this trend shall continue for at least the foreseeable future. I don't know, at least for another couple of decades. And the reasons is that our industry is going through its first big revolution, I'd say, since it started about 120, 130 years ago. So you have a mix of, in the generation side, push for renewable energy, inverter-based resources being added to the
Yes.
grid, solar, wind, BESS, battery energy storage systems. And as we also talked during our coffee, digital coffee, they behave differently from rotating machines. So it causes another realm of challenges for engineers. In the load side, we have the addition of electric vehicles
Huge.
that is expected to increase in the next decades as well. Electrification projects, transportation electrification, data centers. So the load is increasing, and also the economic development, the natural economic development, and for example, I remember in my grandma's house when I was a kid, there was, I don't know, just a couple of outlets. So
Right.
they just had two or three, electro equipment, and today everything is connected. Everything is so the load is increasing with the economic development. So we have this two trends happening on the both ends in generation and the load side. And to complicate things, we also have an aging infrastructure. The reliability today is a key factor. The cost of a blackout today is enormous. We cannot allow that to happen. So I think power engineers are more needed than ever, actually.
And
However, it
I would
seems
caveat that and say even beyond just the power engineering side, down to the electricians that are running the not doing the non
absolutely,
live work,
absolutely,
and
absolutely.
it's a resurgence. And you and I, like I said, we talked at length about this on our call, and it's just like a lot of people don't realize the grid as a whole was very static for the most part. We had most of
Mhm.
our load was very balanced. Generation was there. Yep, we commoditized and we're wheeling power, and that was a different a different thing we had to deal with. But by and large, like you said, with all the inverter based power that we're feeding to the grid, now you have to have smart grids that'll convert and deal with the DC to AC for the traditional transmission, and then just the grid hardening and stuff. We've seen an uptick in brownouts and blackouts, and the big
Mhm.
Texas thing was an LNG freezing issue, but like just in general, I think it's to your point, and I'm echoing the same sentiment. And like I said, that's why we planted our flag. But I do not see it slowing
Absolutely.
down. And the AI evolution, if you will, seems like it's just kind of kicking off.
Mhm.
And of course, those bad boys are definitely power hungry. So,
Yeah, yeah.
and then
And
so
it's just
speaking of
starting, yeah.
AI, do you think and I'm kind of kicking on you here, but do you think AI is going to have any impacts on the power industry?
Yeah, I think AI is already here to some extent. We see it in, I don't know, fault detection, grid automation, predictive maintenance, not in the way of, this large language models that everybody is using, but more on processing data and transforming data into information and useful information. So I think we started in our industry with that. However, I believe the deployment of AI tools in our industry will advance more slowly than in other industries like tech, for example. And one of the reasons is that our profession is regulated. Everything that happens in the electrical industry is regulated. So we have certifications, NETA certifications for technicians and testers. We have PE in the US. So one of the reasons is that so we cannot give a project to an AI tool without an engineer behind it. So for example, complete substation design did by an AI is far from reality today, but an AI tool that reads a one-line diagram and creates an accurate model in a software like ETAP or Easy Power or SIME is more realistic. And things like that are already popping up. So I think AI could be understood as another good tool that will help us to do our work, automate tedious tasks, and optimize other tasks, but not as a thing that will totally revolutionize everything very soon.
So you mentioned like there's a couple of examples that you're already seeing some implementation. What are some of the on the protective side? What can you give us any use cases or what they've already kind of started using it for?
Yeah, I think some algorithms are used that use machine learning and AI are already being deployed for for distribution relays. For fault locator, for example. So in the distribution side, we have, for example, adaptive protection as well. That with the grid, when the grid changes its configuration, the protection can understand that this configuration changed and adapt itself or change settings or and also let's say relays getting the data and running all this data from voltage, current, and everything to predict I don't know, an overload or another dangerous situation or even a fault. There are some works that are starting to be done in this area already. I never worked directly with an AI application in protection, but I'd love to do that when I have the opportunity. But as I said, it's not going to say, okay, put this AI stuff here and it's going to do everything by itself. No, we have to slowly understand how those things work and how they can help us to start with small problems first, then adding up to help us to solve more complex stuff.
I like that. No, I definitely like that. And it's always one of those interesting things. I like to ask guests when we have them on, just because like there's, everybody's got their opinions on it and we're all have our own inherent personal biases and things. But by and large, we can see like AI being very helpful for, like you said, to the point of predictive maintenance and, preemptive triggers and things like that. But once and to your point of kind of implementing it in the test equipment, like you're going to inevitably erode a lot of the skill of the technicians and then we're calling them button pushers, right? And there are certain companies out there that have a reputation because the test equipment's gotten that good, and it's not necessarily AI functionality, but the making it as simplistic and automated as possible, just by using the complex chains of analysis that are available. And so it's very interesting to kind of see. But to that point, I can definitely see tons of value add from a predictive maintenance standpoint. Did a great talk with Drew Welton on that, and it was basically talking about through fault monitoring and using that. And you can literally just kind of the occasions and the readings that you're getting, and now it's like, okay, I don't have to necessarily go do a 6-month periodical maintenance on this thing or whatever the periodicity would be. But now, we may be able to push that off, resulting in cost savings, or get in front of a problem beforehand and resolve something before it becomes catastrophic. So definitely a lot of benefits there, and only time will tell, I guess.
That's it, on asset management, actually, right?
Huge.
Yeah, that's another trend as well. That's another area where AI is going to help a lot. But last thing on AI, I think on the design side, I think many companies in our industry still see a lot of concerns with confidential information. So maybe we're going to see AI being more present in our industry in a couple of years in the future, but it's not, the way that sometimes you see people people seeing too much enthusiasm. So, for example, I can we many companies they are still concerned about sharing information for an
Hmm.
external
Absolutely.
tool, let's say. So if you I don't know if the companies develop their own AI tools internally, so they can use it internally and not putting things on external AI tools, so we can never know what's going to be done with information. I didn't see it happening. This movement starting now, but this is something that could be starting soon, I think.
And it seems like that's one of the major concerns with everybody. I mean, DeepSeek has kind of come in and disrupted the entire
Hmm.
AI scene for all intents and purposes. But with that being said, it's one of those, like, data security, PII, and everything else is a major concern with it being non-native born, I guess you could say, from that
Sure.
aspect. So very interesting times we're living in, to say the least, Madger, I
Yeah,
think. But
yeah, it's a very exciting time to work
absolutely.
on this industry.
Most definitely. And we'll bring it back around to power. I know we got to delve into the AI thing, but I still find it fascinating. Like I said, the protection and control side. And I know you kind of view not only the scientific methodologies and modalities of protection and control, but like it's almost like there's an art behind this stuff. You know what I mean? Like,
Yeah,
and going and doing it. Can you kind of and give us your thoughts on that?
yeah, sure. I think let's say I fell in love with PNC in my first job right after this big blackout that I mentioned, and I had this mentor. His name was Pedro, and I was kind of curious about how the load shedding relays worked, with the frequency relays worked, and how we were going to shed all this load when the generation drops. And he just sat with me and explained. He opened a single line diagram of a substation, protection and metering single line diagram, and explain everything. What was a 50, 51 element, 21 element, why we have this there, what is differential, how the differential works, why we protect the transformer with differential protection, and when the relay trips, when it sends
The
the
feedback.
trip signal to the breaker. And we just spent, I don't know, 4 hours. And
That is awesome.
I think I fell in love right there, at this moment. So after many years later working with that, I agree with you, and I think it's a kind of an art, because uh, there is a judgment involved in making selections, making decisions, and this requires a balance between conflicting objectives, I would say. Like, for example, economics and sometimes selectivity and sensitivity, reliability. So you have all those conflict objectives, and if art is an expression of human creative skill and imagination, let's say, I think there is a pretty big touch of art in what a PNC engineering technician does, because we can achieve the same goal in very different ways, and you are able to let your signature in your work. I worked with another great mentor that I had at Hatch, and he also mentioned that sometimes he thought that it was an art, and he liked to let his signature on that. So when we work together and we see a relay logic diagram, and you you just open it and say, okay, I know who did that. you know I know, because this gate is here, and this kind, okay, he likes to do this loop like this. So
Right.
You know,
A lot of
there's a
people don't
signature.
understand there's 100 different ways to get to the same
That's
outcome
it.
that you need, and it's just a matter of what you want to do to get there. So
Yeah,
definitely
that's it.
funny.
In the same way that you see a Picasso and say, okay, this is a Picasso, right?
Yeah.
So this is a this is his or her
His signature.
logic diagram. It's signature. That's it. So I really enjoy this. I really like this comparative with art.
That is freaking awesome. And then I want to kind of double down on the protection and control side. So we kind of talked about that. I've always been intrigued by it. I've never done any of the relay settings. I've been to distribution stations, seen it in action. It's
Mm-hmm.
always fascinated me. But my understanding there's multiple paths in the PNC career paths you can kind of go down. Can you kind of
Mm-hmm.
talk through like what a career in PNC looks like, and then what are some of the subspecialties that people can focus on?
Yeah, absolutely. I think there are some. The work is a little bit different between medium voltage, low voltage, and higher voltages. So if we're talking about 500 kV, 735 kV, we're talking about just substations, basically, and transmission lines. But when we're going to the medium voltage side, we have a lot of industries, we have distribution, we have everything. So there are different PNCs there, and there are different phases or areas of
Stages,
PNC as
basically.
well. So I would separate them in 4 or 5 areas. The first one is studies. So it's a good place to start, other than the field services, field experience as well. But it's a good place to start study. So I'm talking about load flow, short circuit, arc flash, protection coordination, because understand how the power system behaves under normal conditions and during faults is the foundational knowledge, in the PNC. So I would say start with studies, and when you do a protection coordination study for an industry, for example, and then you do an arc flash, there's a lot of protection there. There's a lot of relay settings there, or LVCB settings as well. So these studies are very important because they are foundational. So a lot of young engineers are start with studies actually. Then we can go to PNC design, as we discussed, would be my second area. Drawings packages, physical design. So everything that goes in a PNC package for a substation, for example, single line diagrams, 3-line diagrams, DC schematics, relay logic diagrams, wiring diagrams, panel layouts, control house layouts, everything there. It's more a design work. Some, of course, we have some some studies that are done preliminarily on a substation project, of course. But then the PNC design, we jump really into the design of the system. So that's another area. Another area, as we mentioned, is field testing and commissioning. It's a whole different area, not whole different, but you have the aspect to go to the field and troubleshoot and test everything and commission and put the thing to work. So it's another realm, I would say. We also have system protection and relay settings. There are PNC engineers that do relay settings for all their lives. So we're talking about, let's say, in a utility, it's a work that is done a lot in utilities. Normally, they develop their own relay settings. Sometimes they give it to consulting firms as well. But I'd say the majority do that internally. And everything that is transmission, everything that is, I don't know, 138 kV or 230 kV up, we're talking about system protection, transmission protection, relay settings. That's another realm, let's say. And the last one would be automation, everything related to automation, telecom, SCADA, communication, cybersecurity, that is trending right now. So everything more related to the communications. It's not protection sometimes, but it's so
Interweave,
connected,
basically, yeah.
related, that we can
Yep.
put that in on the same package and call that also in a PNC area.
Yeah,
I
absolutely.
would say
Well,
that those are
because it
the
all
5.
ties in the control house. It's got a SCADA functionality to it, and it's got
That's
to
it.
talk to everything else for remote monitoring and everything else. So it totally makes sense
That's
from
it.
that aspect.
That's it.
And I was
So
just
I
having a
would say that
conversation with somebody
those
yesterday, actually, with regards to like electrical testers, and it looks like we're even seeing a higher emphasis placed on. And I could be off base here. Like I said, this is just secondhand knowledge, but with Goose messaging and 61850 and BESS in the renewable space and the SCADA, so we're seeing even more of an uptick for more of the comms and the protocol aspects, vice just the traditional PNC and electrical testing aspects of it. So
that's it. That's it.
is it? I
And
always like to
everything
get,
is
it seems
integrated.
like it's all interweaved, but definitely some cool stuff from that aspect. And it seems like we're seeing a lot of technological and innovative pushes that there's almost like a delay in the learning from a lot of your traditional data center folks that are doing switchgear lineups or whatever. And now we're seeing new tech introduced. I mentioned Goose
Mhm,
messaging as one of those that's been really relied on heavily. I know it comes with substantial cost savings on the
mhm.
renewable side. And so some of that's starting to find its way into traditional utility as well, via hybrid substations and things like that. So very cool tech going on out there right now, man. I'm enjoying the
That's it.
space.
That's it. That's it. And absolutely amazing. Yeah, I just did my first substation with 61850 about 1 year ago in a battery
Awesome.
energy storage system. So we just used our Goose messages for the first time. It was very exciting. So yeah, that's a lot of things happening. A lot of things
It's
happening
very
at the
cool, and
same
I'm
time.
loving it. Now, just your that's like a little bit of a sidebar. Do you think we're going to see more of the 61850 protocols being introduced on the non-renewable side? Because it's like I said, it seems like it's very reliable. It's been around. It's and everything else.
Um,
It comes with cost efficiencies because it's fiberized copper lines and things like that. You see it making more of an imprint on the traditional side, or not really?
I think it's we still have kind of conservative approach, especially in North
Mm,
America, in the US and Canada, to fully go in with a digital substation. Well, of course, we have some
yeah,
examples. Some utilities are more prone to that
forward
than
thinking.
others. But I think the key question in the subject is the how the people that are going to maintain this system after that,
Yeah,
how they need to understand that. So the big gap is probably a learning curve and a training. So let's say you have a utility and you have this new fully digital substation using all the fancy protocols 61850,
right.
and all the technicians, all the engineers, all the people that worked with that in the past were not used to that. So
It's a knowledge gap. Yeah,
it's not that easy. When you jump into the details of 61850 and all these protocols and all the how they work, it's complicated. It takes a time to understand. So we have a lot of rules, a lot of words, a lot of terms, and how things are connected. So I think that's the biggest concern with utilities as well. Uh,
so
I I'd love
more of a
to see
knowledge
more
gap
of
than
that.
anything else, and,
It's
trying to
more of a
get all
lot.
the
Yeah,
auxiliaries and ancillaries in place to make sure it works
that's
correctly.
it. That's it. So I think maybe establishing a training program since the beginning, would help with that. But for example, when I was with Hydro-Québec, they were already pushing for a fully digital substation. So they were when I was there in 2019, 2020, before COVID. I worked a little bit in a project. So they were just doing two new substations, fully digital, fully
Interesting.
61850, and it was a challenge. It was a challenge because when you change something that is being has it's been doing that in the same way for decades
Forever.
to a
Yeah.
totally different way, you are going to make some people upset. We have and you deal with a lot of departments.
Yeah.
There's a communication, there are protection, there are the people that do the design, there are people that do physical, so you have to adapt
Hmm.
everybody. So it has a political cost as well,
Yeah.
I would
Absolutely.
say. But the projects went well, and everything's working well. So it's
Good.
more a kind of open mindedness to adapt to this new technology. So I think it's there, and it's lower than we liked, and the people that started this imagined 20 years ago. It was going it's going slower than they imagined, I think, but it's definitely something that is going to happen.
Yeah. I like that. And I want to shift
Absolutely.
gears a little bit. So we've touched or glanced around renewables a little bit. And I know you just gave a recent presentation on the impact of high penetration of IBRs lately, or to that point, inverter-based resources or IBRs, right, on system protection.
That's
What are
right.
some of those key takeaways that we're seeing? I know we kind of, like I said, we're talking the 61850 and some of the other stuff, but what are some of the concerns there? And I definitely want to highlight some of the stuff you talked about with your paper as well.
Yeah, it's totally related to the revolution that we were discussing a few minutes ago. So when we started to add those inverter-based resources into the grid, I don't know, 20 years ago or more recently, 15, 10 years ago, and now it's booming. The penetration of those IBRs was not big, so the impact that they had in the system was not big. So we added, I don't know, 100 megawatt, 50 megawatt wind farm here and there.
Right.
We don't, don't. We're not concerned about the impacts of that on system protection, especially. But right now, with this penetration increasing and increasing and increasing, we started a few years ago to observe some relay misoperations or some potential impacts on relay settings. So more and more people are doing research on that, and we have IEEE groups, working groups in the PSRC.
Can you kind of talk? So we have a pretty technical audience. I want to dive into that. What are some of the symptoms that we're seeing that the IBRs are causing that are now needing to be addressed?
Yeah, for example, the biggest one is all the system, all the protection was thought since the beginning for a system that has synchronous machines, rotating machines on one side, and the load on the other side. That it was like that for the first 100 years of the power system, and now this is changing, right? So all the electromechanical relays that were developed at the beginning were taught and were planned and were designed to deal with uh, higher short circuit currents. Let's put like that,
Gotcha.
because a rotating machine has its inertia, and it when we have a fault, this machines contributes with I don't know, 5 times, 6 times their nominal current. And we have also all the characteristics of this fault in terms of negative sequence current, zero sequence current, positive sequence. So
So
all the
phasing
protection
is
systems
definitely
were
important in
tagged.
this equation as well.
Yeah. For example, when we have a short circuit in the grid, we are basically changing the configuration of electric circuit, right? So that's what happened. So we actually changed the sequence impedances, and the machine responds. The rotating machines, the synchronous
Correct.
machines, respond to that shift in the configuration of the electrical system. But now, when we add an IBR and it's a generation behind an inverter, how it's going to behave in a short circuit depends 100% on the inverter controls. So the inverter controls will dictate how this machine will contribute to a short circuit. These inverter controls are sometimes proprietary information. On the OEMs, they don't like to share it a lot. And we have a lot of other impacts and other studies that are done with EMT software like PSCAD, for example, stability studies. Not the case with protection yet. But when you look to the protection, we see that first thing, what are the two biggest differences? First, a synchronous machine contributes with 5 times, 6 times their nominal current to a short circuit. That's typical. And an IBR contributes with between 1.2 and 1.5 times. Why they do that? Because they want to limit the current that goes through the inverter, so to protect the inverter circuits, right? So the first thing is that the magnitude of the current is way lower than the synchronous machines, and the second one, and maybe the most important that will impact the protection systems, is the first inverters that were put into the grid. They did not contribute with with a negative sequence current to the fault, which is used by a lot of relay schemes, right? So without these negative sequence schemes, you can mess with the distance protection schemes. You can mess up with negative ground directional schemes, and so on. Everything that uses negative sequence can be impact. So if you think in a situation where we have a big generation on one side and the rest of big IBR generation on one side and the rest of the grid that is a stronger grid on the other side, if we have a fault in the middle of a transmission line, the contribution that this big generation will do to the fault is totally different from a synchronous machine. And now with the penetration going more and increasing every year, we're starting to see the impacts of that. So, for example, if you have a day in Texas, I don't know, where it's very sunny and windy, you could have, I don't know, 50, 60% of the total load being served by the IBRs. So the grid is way different than the was expected, was planned to at the beginning, you know. So that's some of the concerns that we have.
Now, are you seeing some movement? Like, what are some of the corrective measures that we're seeing being implemented to address those concerns?
Yeah, one of the measures that are being taken. Actually, there are a lot of researchers doing research on that, looking into this specific problem, and we also have a IEEE PSRC working group working on that. And they just developed, I don't know, a few years ago, 2022, 3 years ago, a new IEEE 2800 standard. And this standard was inspired in other standards internationally, in Europe, in Germany, and so on. Right. And this standard tries to establish a minimum set of requirements for the inverters to help solve this problem. Let's say, so one of them,
because it seems like that's probably the biggest factor is the actual the management of the inverter based resource by the other side. But to your point, a lot of that's being kept proprietary, is what it sounds like. So that's probably one of the encumbrances.
That's it.
Gotcha.
That's it. And for example, in something that we can start to see now is, okay, when a utility is going to the process to accept a new interconnection requirement, they can say, oh, we're going to require that your inverter is IEEE 2800 compliant.
That makes
sense. And then we know that it's going to contribute with the negative sequence current necessary to not mess up with all the protection systems. That's
one of those things. Like I've got a love-hate relationship with regulatory bodies. I think we're definitely heavy-handed in nuclear, but like in these particular instances, the outcomes can be just so detrimental to the entirety of the grid. You have to have that. And I've done conversations again. I introduced you and Drew together and had those conversations, but the amount of work that goes into the IEEE working groups and presenting and putting them up for comment and all that just to come up with this. So I think we're probably in a lag where the regulatory bodies are trying to catch up with a lot of the IBR based stuff, and it doesn't get vetted overnight. Some of this stuff takes years to come to, just to make sure it's been vetted out correctly. So kudos. And you're trying to get into the IEEE side of things, aren't you, a little bit more heavily?
Yeah. I plan to just exactly joining the PSRC group soon.
Beautiful.
Let's see how things evolve, but I'd love to do that.
Awesome, man. And you've got the passion for it, so I know you're going to be an awesome contributor from that point. And I want to kind of shift up the conversation a little bit. So this is one that you and I talked about. I'm obviously big on branding and marketing and things like that. And not many people take the advice, but I've got tons of these veteran guys that are getting out that are very, very strong, and they're like, how do we present ourselves? And I'm like, use social media as a tool, right? And put yourself out there. The proof's in the pudding for us. We've done 0 outbound business development, 15 clients, 100 roles, all that other good stuff. And you and I talked about it. I want to get an engineer's take so somebody can hear it from somebody other than the recruiting guy, right? Like, what's your take on the impact and importance of social media for somebody who's trying to establish a reputation or something along those lines in an industry?
Yeah, I think first thing is it depends a lot on personality. I think not everybody is likes to expose, to share things and to work on their personal branding. But for those that are not opposed to that, I think there's a big benefit. There's definitely a big benefit on working on personal on their personal branding. And today, the first platform that stands out is LinkedIn. Of course, there we met each other actually through LinkedIn. Actually, I landed all my jobs through LinkedIn as well. So this new opportunity that I got from RMS Energy, I think they found me through one of the articles that I published. So I started to keep active and be more active in LinkedIn about 1 year ago, and I've seen how things improved for me in terms of visibility, in terms of opportunities, in terms of building your personal brand. And for those engineers that are not opposed to that, I really recommend that if you want to work on personal branding to advance your career, I think LinkedIn and maybe YouTube videos or launching a podcast as you did, which I think it's amazing, are very good activities. And so one one I think that when you are out there and you're exposing your work, showing your work, and trying to inform people and to teach people actually what you want, it shows that you master a subject. It shows that you can communicate well. It shows that you are not afraid to share your thoughts with everybody. So it shows a lot of things, and all those skills are wanted by all the companies. All the companies want someone that knows technical stuff, knows how to collaborate, knows how to present things, know how to communicate well. So it's just benefits. Of course, again, I think not everybody takes that, and I totally understand that. I know people that don't like it and never will do that,
Right.
but it's a very positive action to a positive undertaking. I think also volunteering to mentor junior engineers and your engineers associations. I do that here in Quebec. Also joining IEEE working groups or volunteering to IEEE local chapters to make presentations. For example, I did one year ago about substations in Montreal for a Montreal chapter. I just reached out to them and said, "Oh, how can I volunteer?" Okay, so just come here and give a presentation about your topic of interest. And I don't know, it was 15 people, 16 people, and they liked a lot. And we shared cards and shared CVs, and they wanted to work for the company they were working in that time. So you create connections, and you're slowly start to build your brand. And when your brand precedes you, it's the half of the job is done, right? So
Absolutely.
what's your how do you see that,
No, and the
Micah,
reason
in
I
terms
asked you
of
that specifically is because I noticed what you're doing. You're putting out the content. It drew us together, and we had a
yeah.
conversation, and I see the benefits added. We've got, gentlemen like Mike Labite and Tom Wire who were doing this while they were active
Hmm.
duty military,
I've been
and the sky
following
was the
them
limit when they
for a
got
long
out.
time.
And so, and like I said, especially, and I gear a lot of this message toward the military folks because they're so
Hmm.
set into that institution. And when you get out, you're navigating all the normal complexities of life, but you're also trying to translate your experience that you had in the military over. And
Yeah.
it seems like your LinkedIn profile, when used correctly as a tool and not a consumption, a means of consumption, it's a living resume for you, and to me, like, just by getting the recognition, and it was part of my business plan, was to be able to have interviews and do this. I learned so much more about the industry, but you're going to get the trust and recognition, omnipresence on the various channels and all that. And I hear it on the digital cups of coffee. Hey, I've never met this guy. I've been watching your podcast, got great stuff. That's a good warm and fuzzy for me, but it just goes to show you the reach at that point. And so you're one that's doing it well. And I would even say, as an engineer, somebody that's going to be putting out something surrounding subject matter expertise, you're essentially putting yourself out there to be critiqued by every other subject matter expert, right? And I saw where Ralph was on one of your posts the other day. Like, those are these extremely like rocket scientists, brilliant guys, and you're going to be critiqued. But guess what? That's another learning experience. That's a chance for engagement. That's a chance to grow. And so just putting yourself out there, and I think for anybody that's self-aware, you're gonna put more thought into making sure that what you're gonna put out, right? I edit religiously with this stuff, perhaps not as much as when I first started, but you're gonna even just from that, you're gonna learn more about whatever it is you're putting out, because you want to go research and do what you're doing to make sure that you're putting out something that's relevant. So I see no detriments to putting yourself out there if that's where you want to go, and it's not going to be for everybody, like, to your point. But you don't necessarily, also, you don't have to put your face out there if you don't want to. You can still share my troubleshooting things. What did I work on? This is the situation we did. This is what we came to overcome it. That situation is probably replicable for 100 techs out there, and maybe 10 of them see that. Well, you just benefited 10 technicians. So I don't see that as a loss for anybody in that. It sounds like everybody wins. So I'm a big fan. I've got a side project in addition to Southern Staffing. And I know we talked about that with Critical Electrical Consultants Group. And my partner in that just does not want to be on camera. He's like, Mike, I like to operate, and I'm like, we have to do this. This is what's important, because nobody else knows your capability, your scope, your skill set, other than your word of mouth, which is still going to be limited in a day when you have all these digital tools. Why not utilize those? You're brilliant in every other thing, so why not be brilliant in this and use that to expand your scope and reputation and everything else that comes with it? So I'm always going to be an advocate, but I always like to get someone on that's coming from somebody like, I don't have a choice. I'm a business owner, right? But a technician or an engineer that's working for a utility may not see the value like I see it, because it's pushing the brand, but you're still building your own personal brand that makes you more marketable in case you ever decide to leave and pursue other avenues. So I think there's tons of benefit to it.
That's it. Your work speaks by itself. Actually.
Well, thank you, my friend. Well, and you hit on something that's very, very big too, that I think is just really a massive concern. I call it the big gray wave is coming, right? We've got all these brilliant older individuals that are transitioning out. We don't have enough new folks coming to the industry, and just spreading awareness of the industry by proxy. You're making introductions that give more people, so we can actually man and keep the grid reliable moving forward from that aspect of it as well. But you touched on mentorship, and that is something I want you to kind of highlight too, and more of a calling card to the other engineers, because I know you're doing this all the time. What's your take on mentorship? How important is it for the next generation?
I think mentoring and mentorship is one of the most overlooked aspects of engineering work. That's what I see in all the organizations that I worked. I think the majority of the companies do not give it the right value. Do not put much effort in that. Not, again, as the same in camera. Not everybody's suited to be a mentor, but I think companies should identify the ones that are and invest in mentoring. This is in my case, it's just natural for me. I just love to do that. I love to teach. I love to explain stuff. And now that I'm getting older, and I see that the younger engineers need more than ever some kind of guidance, I'm trying to do that on a volunteer basis as well. So I took, I don't know, 4 or 5 different young engineers, and I'm mentoring them. So I meet them once in a month or once in a few weeks. To discuss all kinds of subjects, technical stuff or career development, or I'm thinking of changing jobs. How can I prepare for an interview? Do you have any tips? Or I'm lost in my career. What do you think? So as you pointed out, we have a lot of good engineers and very experienced engineers that are retiring, and we're going to lose this expertise very soon. So I think they could be more. Companies should start thinking about putting those those folks that know everything on a mentoring role as well. Of course, some of them do that. I was lucky enough to have great mentors in the past, and sometimes you just don't have time. You have to make time to do mentoring. So that's one thing. Companies should do that. But also young engineers, I see they looking more for that, because when you think about, I don't know, if I think about the start of my career 10 years ago, 15 years, 17 years ago, actually
Right.
this year,
We're getting old, Madjer. That's all it
almost
is.
17. Oh my God. At that time, we were still living in a world where we were supposed to work all our entire careers in one or two companies, and then you just stay there, and you end up learning something. If you spend 5 years, 6 years, seven
Right.
years, you're going to learn something, right? But now it's a different market, it's a different society, it's a different the technology evolved a lot. It's a way easier to change jobs because of remote work and everything that we are seeing. So the tenure of the engineers and technicians and other professionals in some companies is lower today.
It's
So
definitely
they
lower. I've
just
seen
don't
that
have time,
trending. Yeah.
They just don't have time. So an engineer starts a new in a new job, and the company, is difficult for the company to say, okay, let's go to it has to learn. Let's do it slowly, how it should. So it's going to take 1 year, 2 years. So let's invest on this development. Sometimes they stay there, and they don't even know what is going on and why they were hired. And after 1 year or two, they want to
Right.
leave. You
Yep.
know. So I think mentoring is key. Is key. I try to do my part of the work, mentoring some young engineers, and I've seen other colleagues doing that as well, as my colleague Joshua Tim from Power
I know
Transformation.
Josh. Yep. Or I
Very,
follow him anyway. We've never met, but yeah.
yeah, he's doing a great job on that. I actually
Hmm.
took one. He is still my mentor,
Very cool.
and I learned a lot from him. So yeah, there are those guys that are doing that, and I think this younger generation understands that as well, and they are looking for more mentoring opportunities. So that's it. I think it's key, and the industry, the companies should take a look more carefully on that, and actually structure mentorship programs inside the companies.
Well, and I will say we are starting to see an uptick. I've got several clients, like I said, and all training and curriculum development, and all that. I
Hmm.
think, again, it was the industry. We had all these things popping up, and within the NETA construct, you don't keep your NETA certification if you go to a non-NETA
That's
accredited
it.
company. And then just the scope of work, we're past the design phase for most of this stuff. So now we're getting into implementation and EPs, all the EPC phases that are going on, and they just don't have the
That's
manning to
it.
do it. And with the requirements for a project manager to have a 3 or 4 on site or whatever it may be, companies are
Hmm.
now seeing that, and the pay rates are just going up. I've seen a $10
Hmm.
jump in hourly bands from one at every level from 1 through 4. And so that's only tenable for so long before there's no profit margins to be had,
That's
right?
it.
So
That's
there
it.
has to
That's
be
it.
something to cover the overhead cost. And so we are seeing a lot of efforts to build out internal, they're calling them, curriculum development or workforce
Hmm.
development roles. And I'm familiar with several of them that are standing them up either in renewables or for NETA or for protection and control. So there are
Hmm.
efforts to address it. But I think the major encumbrance was really just comes down to it's a cost center, right? It costs to
Yeah.
train these individuals. And that's
Hmm.
something that also has to be managed in the overall P&L construct. So can you
Hmm.
get away from it? No. But I think companies are finally at a pivoting point here, where you either you have to, or we're going to have to continue training these, keep paying the exorbitant or the exorbitant rates as they continue to climb. relatively exorbitant depending on who you speak to, right? But it's all supply and demand driven. That's a universal law. It never changes. And that's usually going to determine the pay rates. And I think they're trying their best to get ahead of that, you know? So all I know is it's a heck of a ride. It kind of feels like the Wild West in power right now. And we're almost like on this rebirth of things with all the new technologies that are coming out and different generation, you know, methods and everything that we're now having to encompass. And then EMP blast are now more concerned than they were in the past, and everything else that you're seeing. So it's just a truly fascinating industry to be in.
I totally agree.
Well, Madjer, my friend, we're at an hour and 8 minutes here. So I told you it'd be right about an hour when we were pretty damn close on that. And I enjoyed the heck out of it. I know you are like me. You like to share your knowledge. You're a mentorship type individual. And thank you for joining us to hop on here. Where can people find you if they want to connect via LinkedIn or wherever?
Yeah, I think the best way is on LinkedIn. Go there, look for Madjer Santos. And
I don't think there's too many Madjer Santoses over there.
No, probably just one or two. Electrical engineer, probably just one.
Yeah. Fair enough. No, awesome, man. And like I said, thanks so much for hopping on. It's always a blast, and I enjoyed the heck out of it. And like I said, we met via 1,000 Digital Cups of Coffee. And it's just amazing the people that we run across. And I learned so much about the freaking industry. And I'll make a quick plug for everybody out there. Pick up the damn phone and call some people. Get on the phone. Have a conversation for the sake of learning and just having a conversation. You get to do cool shit like this, right? So
That's it. I'm totally over it. Yeah. You understand.
Brother.
We were very alike.
Yeah, man. Yeah. It's a whole damn industry, and I just run across like you're not an anomaly with regards. I mean, you're very, very brilliant, but it's just the amount of people that have true passion surrounding this. You know what I mean? And all the stuff that's coming down the pike, and just being able to share some of that stuff with the audience and stuff is awesome. And thanks again for hopping on with me, brother. I appreciate you.
Thank you, Micah, and congratulations for this brilliant work that you're doing, our podcast and Southern Group, everything. It's amazing.
Really Thank you, sir. We're just trying to be a little bit of a sliver of a good, a force for good out here, and make a little money. Doesn't hurt along the way, but we're going to keep doing what we can to help everybody.
Absolutely. Thank you,
All
my
right,
friend.
my friend. Well, everybody, until next time, Micah out.
Bye-bye.
Thanks for tuning in to the Power Relay with Micah Clay. If you enjoyed this episode, feel free to like, subscribe, and leave a review. For more insights, contact info, job offerings, and other content, check out our Linktree sites at Linktree/Micah W. Clay or Linktree/Southern Staffing. We'd love to hear any feedback. And if you know anyone we should highlight, feel free to drop us a message. As always, thanks to those who work tirelessly to keep the lights on. Until next time.